So P is on the bearing of 0, 15 degrees from Q. So Q from point Q. 0, 15 degrees. 0, 15 degrees from Q. So this is P. Okay. Now, and then it says R is on the bearing of 140 degrees from P. So 140 degrees from P. So that's point R. Point R. This is 140 degrees. So we're going to have E here. I'm going to have B here. Why? Because we can have alternate angle here and here. This will remain from the North Pole. So because eventually going to be a triangle, so with angle P, the total sum of angles at angle P would be addition of A and B to get angle P. So if here's 140 degrees, then from south to the line we give this angle, so the total will be A plus B. So that's for that. Now let's join our shapes together. So this will give us let's join our shape together. So that's our shape. So if QP is 24 meters, QP is 24 meters, and QRP is 30 meters. 30 meters. So the question says, if, find the distance between R and Q. So we're looking for this side, and for us to do that, we need to get A. So let's analyze. So A is equal to 15 degrees. Why? Alternate angles. A is alternate to this angle here, and then B is equal to 180 degrees minus 140 degrees. Why? Angles on a line. So B is equal to 40 degrees. So altogether A plus B. So let's say Q angle P. Q angle P R, that's the angle P, because now it's a triangle. Q angle P R to the side is equal to A plus B. That's equal to 15 degrees plus 40 degrees. And what is that? 55 degrees. And the next thing is using cosine rule. Using cosine rule. So A. Now we can proceed. Using cosine rule, QR squared is equal to 24 squared plus 30 squared minus 2 times 24 times 30 times cos 55 degrees. And that will give us 576 plus 900 times cos 55, 825.95, and that will give us 576 plus 900, 1476 minus 825.95. That will give you minus 825.95. 650.005. Line Q R squared is equal to line 650.05. When we take square root of both sides, so line Q R is equal to square root 25.50. So, but the question says we should totally significant figures. So 25.50, sorry. Okay. Since I'm going to approximate two significant figures, let me just write down 496. So therefore, line Q is equal to 25.5 kilometers to three significant figures. Then B says find the bearing of R from Q. The bearing of R from Q. So bearing of R from Q would be from here to this line. So we need to know this angle. Let's call here theta. So theta plus 15 degrees will give us a bearing. Since from the bearing of R from Q involves measuring from the north to this line, because it's this line that's connecting Q and R together, and that will be this angle from this line to this line, which is this angle in the triangle plus 15 degrees. So I'm going to say B, the bearing of R from Q, and Q is theta plus 15 degrees. So using sine rule, sine 55 degrees over 25.496 equals to sine theta over 30. So sine theta is equal to 30 sine 55 degrees over 25.496. Sine theta is equal to 30 sine 55 divided by 25.496, 0.9639. So theta is equal to arc sine 0.9639. So theta is equal to 0.9639. That's 74.56 degrees. So theta is 74.56 degrees. But we say that the bearing, so okay, but the bearing of R from Q is theta plus 15 degrees. So I'm going to say which implies that bearing, which implies that okay. So we say which is equal to 0 plus 15 degrees, and that's equal to 74.56 degrees plus 10 degrees. So 74.56 plus 15, 89.56 degrees. So the nearest word correct to 2 dp, so to 2 decimal place. It's already corrected to 2 decimal place, so is equal to 2 decimal place. That's so C. C says find the bearing of Q from R. Give your answers correct to 1 dp. Bearing of Q from R. So what do we do? The bearing of Q from R will be from the north to this line. Okay, which means that from here to here is 180. What about this angle? So let's call it theta, and we know that from here to here is 180. So how can we get here? We can get here from here. How? From alternate angles. So let me call here. We cannot have 2 theta. So let's say alpha. So we see alpha is equal to theta equal to, so what is theta? 74.56 degrees. Why? Alternate angles. So this angle from here to here is alternate to from here to this side. So look at what we have. We have this here, and then turn, and then we have this. So here is north, here is south, this is north, this is south. So from the north to this line, so we basically get theta into this part here, alpha. Remember, it's not like this. It's from the south to the line, so this is alpha. So if you take this to be a transversal, and if you take this to be parallel lines, and this to be a transversal, so both angles are within the parallel lines, and one is on the other side, the other is on this side. So that fulfills the condition for alternate angles. So theta is alternate to alpha. So theta is 74.56 degrees, but we know that the bearing of the bearing of Q bearing of Q from R is equal to 180 degrees plus alpha. It's equal to 180 degrees plus alpha, and this is equal to 180 degrees plus 74.56 degrees. 74.56 degrees alpha. Oh, sorry. Theta is only for this angle. That's the angle inside this triangle, these two lines, between these two lines. So it's going to be from the north to this line. So it's not theta. It's supposed to be, what do I have here? Q. And okay, so let me say this angle. Let me represent Q by, let me call this this angle like this. Let me say it is I already got alpha. Let me call it beta. So alpha is equal to beta. So and beta is angle Q, which is from the beta is just from this line, triangle for QPR. So this line and this line, so it's just from here, that's theta. So theta plus this 15 makes up angle beta, which is this from the north to the line, alternate to the line to the south. So it's going to be 89.56 degrees, and here will be 89.56 degrees. So alpha equals to beta 89.56 degrees. So this will give us 180 degrees. 180 plus 89.56, 269, 169.56 degrees. And it says correct to 1 decimal. So this will give us approximately 269.6 degrees to 1 decimal. A man travels from a village X on a bearing of 060 degrees to a village Y. So village X 60 degrees, O 60 degrees to 3-digit bearing, O 60 degrees. So a village Y, okay, which is 20 kilometers away. So the distance is 20 kilometers. And so from Y, it travels to a village Z on a bearing of 195 degrees. So 195 degrees is going to, since it's now more than, it's from the north, so here is 180, so 195 will be like this. So, and from Y, he travels to a village Z on a bearing of 195 degrees. If Z is directly east of X, Z is directly east of X. So from X, we draw a line to meet C. So this will give us this angle. So let's call here. And from here, this is Z. Z. So we have this line. This is not okay. So we're not given a distance. We're given a distance. We are going to look for it. Okay. So the question says, if Z is already east of X, calculate correlatively significant figures A, Y from Z. So let's see. We can know this angle alpha, and then we need to solve for this. Already this is 90 degrees, yeah, because if it's directly east of X, then from the west to the north is 90 degrees, but we don't know here, so we need to calculate for this angle, and we can only do that. So let's leave this first of all. So let's analyze solution A. So alpha is equal to 60, 90 degrees minus 60 degrees. What's the reason? Complementary angles, because from here to here is 90 degrees. So these two angles make up 90 degrees, which from here to here is 90 angles in the first quadrant. Sum of angles in the first quadrant. So alpha is equal to 30 degrees. So if alpha is 30 degrees, what else do we need to get before we proceed? Okay. So let's say if alpha is 30 degrees, we can, so to get the distance of y from z, and so we're going to look for this side. Of course, that means we can also look from here because we need to have knowledge of two angles. So we're going to look for this side because alpha is given and we want to know here. Then what is this angle? So yes, 90 degrees. So good, this was given to us. So now let's look at our question, 195 degrees. But for us to proceed either with sine or cosine rule, we already know this angle, which is 30 degrees, and we're looking for YZ, which is A, question A. So if we are going to use sine rule, we need to know one angle and this side, and then another angle and either another angle and this side, or the side known or the angle unknown. So let's say from here, this one given to us here, we have here to get this angle. First of all, we told that here is 195 degrees. So 195 degrees, which will give us, if from here to here is 195 degrees, then this angle here would be what? Let's call here B. Since so whatever this angle is, we alternate to this angle. So with that, we can get the whole of this angle. Since from the north to Z, from the north to this to the west is 90 degrees, this part is 90 degrees. So we need to get, let's label here as C. We need to know C. So C, let's get B first of all. So B is equal to 195 degrees minus 180 degrees, and that will give us B is equal to 195 degrees minus 180 degrees. 195 minus 180, that's 15 degrees. So because 15 degrees plus 180 degrees will give you the whole of the north to this line, which is this angle here, the whole from here to here. So since from here to here is 180, then this part will be 15 degrees. So and 15, B is alternate, so B is C is equal to B. C is equal to B equal to 15 degrees. What's the reason? Alternate angles. Now that we've known C, so let's get this angle. So X angle ZY, X angle ZY, that's the total angles at Z is equal to 90 degrees plus C, 90 degrees plus C, which is equal to 90 degrees plus 15 degrees. So 90 degrees plus 15, that's 105 degrees. So now we can use either cosine or sine rule. So from what we have here, we have two angles and one side given. So we can compare. This angle is known, this side is known, this angle is known, but we are going to look for this side, which is YZ. So using the sine rule, and I'm at A. So A, using the sine rule, we're going to have sine Z, which is 105 degrees over, what's the side, 20, equal to sine alpha is what, 30, sine 30 degrees over YZ. So YZ is equal to 20 sine 30 degrees over sine 105 degrees. So YZ is equal to 20 sine 30 divided by sine 105. That's 10 points. 10 points to a 5. So what? Question says to trace significant figures. That will give us, so YZ, therefore y is equal to 10.4 kilometers to SF. B. B says we should calculate the distance of Z from Earth. So Z from Earth. So which means we need to know this side. And we cannot know this side when we don't know this angle. So how do we get to this angle? So let's call this let's say this is angle beta. I've already used alpha here, so angle beta. So to get beta, we know this side. Beta is in this quadrant. So let's say we have something like this. We have this line, and then we have this line. So already for alpha, so to get alpha, let's call here. I have BC. I don't have D, so let me put D here. D. Let's have D. Okay. Now let me analyze here. So here is angle beta. So this is D, what we have here, and then here's 15 degrees. So all these are angles on a straight line, or in this quadrant. They are all angles in this quadrant. So what do we do? Now okay, these are not angles on a straight line. So what these are angles on this quadrant. So they are all complementary angles. So first of all, I'm going to say D is equal to alpha. And what's the reason? D is equal to alpha. What is alpha? Alpha is 30 degrees. Alpha is 30 degrees. What's the reason? Alternate angles. So D is alternate to this line here. You have something like this. It's equal to 30 degrees, which is alpha. So this angle is alternate to this angle. Omega is joined to this transversal. So this is alternate to this angle. Now 15 degrees is already known, so we're going to say beta. So beta is equal to, or beta plus 15 degrees, beta plus D plus 15 degrees, which is, you know, D is, this part is B. So beta plus D plus B is equal to 90 degrees. What is the reason? Complementary angles. So beta is equal to 90 degrees minus D minus B. So 90 degrees minus, what's D? D is 30 degrees minus, what's B? B is 15 degrees. And that will give us 90 minus 30 minus 15. That's 45 degrees. So now that we've gotten this angle, we can now look for this side y from Z. So using sine rule, we can, so say sine 45 degrees over yz over x z is equal to sine 105 degrees, sine 105 degrees over 20. So x z is equal to 20 sine 45 degrees over sine 105 degrees. So x z is equal to 20 sine 45 divided by sine 105, 14.64. So x z is equal to, therefore x is equal to 14.6 kilometers to the significant figures. A surveyor standing at a point X sights a pole Y due east of him. So it's here point X. So standing at X sights a pole Y due east of him. Due east is going to be like this. So let's call this Y. And then due east of him and a tower Z of a building on a bearing of 0.46 degrees. A tower Z on a bearing of 0.46 will be like this. So this is Z, and then yes, 0.46 degrees. 0.46 degrees Okay. So after walking to a point W, a distance of 180 meters in the southeast direction. Southeast. So this is, remember, this is north, this is east, this is south. Southeast will be this way, 180 meters. Point Z. Let's draw our bearing. Okay, so this is point Z. Southeast direction. He observes the bearing of Z. Now, from this is after walking to a point W, or to a point W, so this is W. After walking to a point W, a distance of 180 meters in the southeast direction, he observes the bearing of Z and Y. The bearing of Z from here, he observes the bearing of Z and Y to be 300. For Z, the bearing of Z is 337 degrees because Z came first before Y, and then 337. Z here, Z and Y, 337 degrees and 050 degrees. So this 337 degrees is the bearing of Z from W, and then this 50 degrees is the bearing of Y from W. So from W, Z, draw your line to connect. That's it. And then from here, draw your line to connect. Draw your line. Okay. So and that's it. Alright, so let's get our bearing. So from W, here is from 3, from the North Pole to this line is 37 degrees, and then from the North Pole to this line is 50 degrees. 50 degrees. Okay, and the distance is 180 meters. So calculate correct to the nearest meter line XY. Line XY and 2 line ZW. Line ZW. Alright, so from here, so XW, okay, southeast direction. So now let's look at what we're going to do. So here, from this to W, so we need to know here A. Let's call let's call here A, and then we need to know here this is B. I'm sure this line is B. It's accurately drawn. If we draw this naturally, it should be like this. So it should come 337. Should come like this. Yeah. So, okay, so we need to know here. We'll call this E. Let's say B, and we need to know this small angle, which is C. Let's say this angle C is C, and so angle C here. So we also need to know this angle, which is D. And which other angle we need to know here? Angle E, and then we need to know here angle F. Angle F. Then for now we don't have anything. Okay, probably we need to know here too. F. This is G. And what else do we need to know? We need to know, okay, do we have anything to do with this line? Triangle XWY. Okay, maybe if there's need for this, we need to know G. It will call this H, but if there's no need, let's leave it like that. Let's leave it like this for now. So now let's do our analysis. So here, A is equal to A is equal to A is equal to 90 degrees minus 46 degrees. That's equal to 90 degrees minus 46. 90 minus 46. That's 44 degrees. What's the reason? Angles, complementary angles. So A is that Now B is, so since A is this, A is 44 degrees, now let's find B. B is equal to 46 degrees. Oh, B is equal to A, equal to 46 degrees. What's the reason? Alternate angles. So what about C? So let's come down here. C is alternate to D. So for us, we need to get D first. D is, so our D is from the north to this line. So that's 337 degrees. So 337 degrees with D makes angle at a point. So D is equal to 360 degrees, or let's say D plus 337 degrees is equal to 360 degrees. Why? Angles at a point. Angles at a point. So D is equal to 360 degrees minus 337 degrees. And that will give us 360 minus 337, 23 degrees. So C is equal to D, equal to 23 degrees. Why? Alternate angles. So our C is 23. So let's get E. E, for us to get E, we need to, our E will be just like this. So how do we get it? We get E from, so let's get F first. Let's get our F first of all. F is gotten from, F is 45 degrees. Why? Because from here, it says, start to pull YG east of him and a towards Z of a building on a bearing of 0.46 degrees. And after walking to a point W, a distance of 180 meters in the southeast direction. So the southeast is just like this. So between southeast is just like a bisection of this quadrant, the northeast quadrant. So that will give 45. If the northeast, from the north to the east is 90 degrees, a bisection of it will give 45 degrees. So that's why angle is at 45 degrees. So it's called the southeast direction. Southeast direction. Okay, so now let's get, we need to get E. So if I get E by, let's get here. So we already have F, G. So let's go here H, and H is gotten from, so H is H is equal to F, which is 45 degrees. Why? Alternate angles. So H is equal to F. This angle is alternate to H. Now HED will give us complementary angles. So H plus E plus D is equal to 90 degrees. Why? Complementary angles. So E is equal to 90 degrees minus D minus H. E is equal to 90 degrees minus D. What is D? D is 23 degrees. And what is H? H is 45 degrees. So that's equal to what? 90 minus 23 minus 45, 22 degrees. What do we have left? Have you looked for G? So G is equal to, G is equal to, so if G is equal to 50 degrees, G is equal to 50 degrees. Y, alternate angles. So this angle is alternate to this angle, G. Now that we've gotten this, the question says, number one, find line XY. So line XY, which is this line here. To do that, that's in triangle XWY, in triangle XWY, which is E. And I'm looking at Roman figure 1, so write it again. A1 in triangle XWY, using the sine rule. Using the sine rule, we're going to have, so let's get the total angle here. E plus D. Our E is 22 plus D is D is D is 23, and then plus 50, 95. The angle here is 95 degrees. So using sine rule, using the sine rule, yeah, with this angle is known, and we're looking for this side, and this angle, this side is known, and then we're looking for this side. So okay, good. So we need to get this angle for us to be able to use the sine rule. So this angle will be, so let's call it H. I'm calling H, let's call it I. Angle, let's call it angle letter I. So I is equal to, so you can say it, since here is 50 degrees, this main angle is 40 degrees. So 40 degrees here with alternate angles, or we can say I plus G equals, so I is equal to 90 degrees minus G. 90 degrees minus G, which is equal to 90 degrees minus, here G is 50 degrees, and that's equal to 40 degrees. Why? Complementary angles. So now that we know this part, so this is a known angle, this is a known angle on the known side, then a known angle and on a known side, so we can use the sine rule. So using the sine rule, sine 95 degrees over xy line xy is equal to sine 40 degrees, sine 40 degrees over 180. So xy is equal to 180 sine 95 degrees over sine 40 degrees. So xy is equal to 180 sine 95 divided by sine 40, 278.96, 278.96. And we're told to correct our answer to 3, to the nearest meter rather. So xy, therefore xy is equal to 279 meters to the nearest meter. So that's A1 and 2. The my figure 2 says ZW. So ZW is in triangle XWZ, and triangle XWZ using the sine rule. So now in triangle XWZ, this E is part of this triangle, so we're only using this E, and here we're going to add these two together, and here we're going to add these two together. So B plus C is what? B plus C. B, where's B? B. Oh, okay. B plus C is B. 46 plus C is what? 23. 69 degrees. And A plus F. A is 44 degrees. And F is what? F is 45. That's 45. 89 degrees. That's 89 degrees. So we are looking at this side. So we have two angles and one included side. Two sides of two angles. So sine 69 degrees. Sine 69 degrees over 180 is equal to sine 89 degrees over WZ. So WC is equal to 180 sine 89 degrees over sine 69 degrees. So WZ is equal to 180 sine 89 divided by sine 69, 192.777. So therefore WZ is equal to 193 meters 193 meters to the nearest meter. Nearest meter is 193 to the nearest meter. B says if n is on xy such that xz is equal to zn, find the bearing of z from n. So if n is on xy, line xy, so the point n, let's mark point n there, such that line xz is equal to, so xz is equal to xzn. Okay, so yes, so let's put it here. Okay, so what it means that line xz, this line x is equal to line zn for zn, same distance. So that means this line is equal to this line. Okay, so find the bearing of z from n. So this is point n. Call this point n. And call it point n. So we're going to find the bearing of z from n. So from n, measure to this line. Okay, so here first of all we're going to get this angle. Then we know that this from the north to the west is 270 degrees. So we need to get this angle. So let's say the bearing of, let's call this I. You see the last letter I used was I. Again, this should be J. So the bearing of n, bearing of z from n, bearing of z from n is I is equal to 270 degrees plus J. So J is gotten from, what is J? Since this line is equal to this line, so we say since x z is equal to zn, therefore A is equal to J. So that means that is equal to what? A is what? 44 degrees. What is it? Base angles of isosceles triangle. So that's the reason. Okay, so if that be the case, so we've already gotten J, so we say therefore the bearing of z from n is equal to 270 degrees plus 44 degrees. That's equal to 270 plus 44, 314 14 degrees. That's the answer. The boy cycles from his house H at 30 kilometers per hour on a bearing of 110 degrees for 40 minutes until he reached a school S. Then he circled on a bearing of 230 degrees at the same speed until he reached a stadium D after a further 30 minutes. Find the distance and the bearing of the stadium from the boy's house A. B. What is the bearing of the boy's house from the stadium? Give your answers to the nearest degree. We're going to start off by, first of all, getting the distance in this journey. So speed, what is given to us is the speed and time. So we need to get our distance. So the speed is equal to distance over time, and distance is equal to speed times time. So, and the unit speed is given to us in kilometers per hour, but time is given to us in 40 minutes. The unit of speed is usually kilometers per hour or minutes per second. This means that if the distance is in kilometers, then time must be in hour. On the other hand, if distance is in meters, then time must be in seconds. but here the speed is in kilometers per hour, but time is given in minutes. So what do? We need to convert this time to hours. So 60 minutes is equal to 1 hour, 40 minutes is equal to 60 minutes, 40 minutes equal to x hours. So when we cross multiply, we're going to have 60x equal to 40. So x equal to 40 over 60 hours. Okay, so we're going to say for the first part of the journey, the distance is the first part of the journey. Distance is equal to speed, which is 30 times 40 over 60. 0, 0, 2 here, 2 here, 3, 2 here, 1, 2 here, 10. 10 times 2, 20 kilometers. Once your time is in hours, your distance in kilometers. The second part of the journey, distance is equal to 30 times. So then he circled on a bearing of 230 degrees at the same speed, which is 30, at the same speed until he reached a stadium D after a further 30 minutes. So 30 minutes, just as what we did here, converts to hours with 30 over 60. 0, 0, 2 here, 1, 2 here, 2, 2 here, 1, 2 here, 15. So that will give us 15 kilometers. The next is to get our diagrams from, so sketch our diagrams from this information and then solve the questions. So a boy circles from his house H at 30 kilometers per hour on a bearing of 110 degrees. So let's call here H. So 110 degrees will be this one. Well, let's say this is H and then this is H and then this is, so the house and school. This is S. Then okay, so let's put here 110 degrees, and then the distance is 20 kilometers. Okay, so from the house to the school, the distance between the house and school is 20 kilometers, and the bearing of the school from the house is 110 degrees. And then he circled on a bearing of 230 degrees at the same speed. So from here, 230 degrees will be in this quadrant. It's going to be like this. From what I'm saying, this line is short because the distance is 15 kilometers. 15 kilometers. Okay, so we join them together. So that's it. So here is D. What's D? Okay. So now let's analyze our diagram. So we need to, this is 110 degrees. So we need to know here. Let's call here. We cannot get since this line, the line connecting H and D is not resting on the east. We cannot get this angle just from complementary angles, because this is not, we still have an angle here which we don't know, and we don't know this angle. So let's come over here. We can get to know this side from complementary angle, but let's resolve here. So here from the south, the bearing was 230 degrees. 230 degrees. Okay, so let's find this angle. Let's call it A. Let's call it A, and then let's call here B. Okay, so if we call there B, so we say from here, this is all we have to work with for now. So we're going to say A is equal to 230 degrees minus 180 degrees, and A is equal to Hope you understand why it's 180 degrees, because from the north to this line is 230 degrees. So from the south to this line, which means this angle here was gotten, this angle here is simply 180 degrees. This 230 degrees was gotten by adding this part here to here to 180 degrees, which is from the north to the south. And then from here, A and 180 degrees gave us 230 degrees. So to get E, we subtract 180 degrees from 230 degrees. Fifty degrees. 50 degrees. So if it's 50 degrees, you know that from okay, now what we have here is something like this. So let me use this part again. What we have here is something like this. Okay, and this is what we have. So A is alternate to B. So this says that 110 degrees is alternate to A plus B, because from the south to this line connecting H and S is alternate to the north to the line connecting H and S. So this is exactly what you have: north line, south to the line. So A plus B here is alternate to 110 degrees. So you can say A plus B is equal to 110 degrees, and that will give us Y. Say alternate angles. So B is equal to 110 degrees minus A, and B is equal to 110 degrees minus what's A? 50 degrees. So B is equal to 110 minus 50, that's 60 degrees. Okay, so next is we're going to look for the distance between what's the distance, find the distance at the bearing of the stadium from the boys' house. The distance of the stadium from the boys' house, so HD. So we are going to use the cosine rule now, because we know B is 60 degrees, and then we have two given sides, and the angle is between the two given sides. So this fulfills the use of the cosine rule. So we're going to say using the cosine rule. So it's like H D squared is equal to 20 squared plus 15 squared minus 2 times 20 times 15 cos 60 degrees. 400 plus 225 minus 2 times 20 times 15 times cos 60, 300. The 400 plus 225 is 625. 625 minus 300, 325. 225. So HD times HD is equal to the square root of 225. Line HD is equal to square root 325 is 18 points. This is my 028. But the question tells us to correct our answers to what? Because we're not told. Okay, so we're not told to the number of significant figures our answer should be corrected to, but I can pick mine. So I'll choose to correct my answer to the nearest meter or nearest kilometer. So this is approximately 18.0 kilometers, or 18 kilometers. 18 kilometers to the nearest kilometers. So that's my answer. Then it says find the distance and the bearing of the stadium from the boys' house. So the bearing of the stadium from the boys' house. So from the boys' house, so what we're going to do is that first note the line connecting the boys' house and stadium, which is this HD. So we're going to get our angle from here, touch here, and then end here. So which means for us to get the bearing of the stadium from the boys' house, it's going to be 110 degrees plus this angle that is part of the triangle. This angle that is as part of this side H of the triangle. So we're going to say the bearing of the stadium, on the boys' house. The boys' house is 110 degrees plus alpha. 110 degrees plus alpha. So alpha plus 110 degrees will give us the bearing, because from the north to this line includes 110 degrees plus this angle of the triangle. So let's get this angle of the triangle. So using the sine rule, the triangle fulfills what we have here. The conditions fulfills the sine rule, because an unknown angle and its side, a known angle and a known side. So using the sine rule, sine 60 degrees over 18.028 equals to sine alpha over 15. So sine alpha is equal to 15 sine 60 degrees over 18.028. Sine alpha is equal to 15 sine 60 divided by 18.028, 0.7206. 0.7206. So alpha is equal to arc sine 0.7206. Alpha is equal to 46.10 degrees. So that's for alpha. And you know the reason we got alpha is because we wanted to add it to 110 degrees for us to get the bearing of D from H, because it's part of the bearing of D from H. So now we're going to get it. We have it here. So the bearing, therefore the bearing of D from H is equal to 110 degrees plus 46.10 degrees. 6.10 degrees. And that will give us plus 110, 156.10 degrees. So that is what we're going to get. The bearing of D from H is equal to 156.10 degrees. So that's for A. B says what is the bearing of the boys' house from the stadium? What's the bearing of the boys' house from the stadium? This time around, we're going to take our bearing from the north to this line, connecting the boys' house and stadium. So this back bearing or reverse bearing. So first thing first, the bearing of D from the boys' house, which means our bearing was taken from H. Now, after we've gotten that, the question says we should get the bearing of H from the boys' house. So that's like back bearing or reverse bearing. All right. Now, also in this case, what we notice is that we have something here. From the north to the south is 180 degrees. So, and then here we have alpha. Let's call from the south to this line. Since we don't have much information, we could say that A here is alternate to this angle, but it's not useful when we are calculating the bearing of H from D, because already we know that from the north to this point is 180 degrees. So what we use saying that here is equal to alternate to A, it's not useful, since already from here to here is 180 degrees. The only thing we need to know is that we need to know this from the south to this line, so that we can add it to 180 degrees to get the bearing. So what we're going to say, let's call here beta. So the bearing of the boys house, the bearing of the boys house from the stadium is equal to 180 degrees plus beta. So what is beta? So our focus now is to determine the value of beta. To get the value of beta, we're going to make use of another significant, observe something else again. So this is what we have. So take note, this is H and then this is D. Remember, it's reverse bearing. So from the north to this line, so from the north to this line, connecting H and D, from the north to this line, this is 110 degrees plus alpha. 110 degrees plus alpha, which is here equal to 156 degrees, which is 156.10 degrees. It's also alternate, so from the south to this line, and that will give us beta. So that's what you have to, from here to this line, it's alternate, so from here to this line. If that be the case, so we see that since beta is equal to, since beta is equal to 156 degrees, 156.10 degrees, using alternate angles, then bearing, then the bearing of each from D is equal to 180 degrees plus 156.10 degrees. And that will give us 336.10 degrees. That's answer. A plane flies 400 kilometers north and then a further 600 kilometers on a bearing of 070 degrees. How far is the plane now from its starting point? A. B. On what bearing must the plane fly so that it returns to its original point? C. How far north and how far east is the plane from its starting point? So let's start by saying that the starting point, let's indicate starting point is A, because the question says that the plane flies 400 meters north. North means it's going up. So if this is the starting point A, so let's say the plane flies upward north. Plane flies north. Okay. So these are cardinal points A. And then from point A, it flies and then a further 600 kilometers on a bearing of 070 degrees. So this, let's call here point B. From this point 070 degrees. Let's call here the final destination to there's 70 070 degrees, and this is 600 kilometers. 600 kilometers, and here's 400 kilometers. So let's connect these two points. Okay. That's the distance, 600 kilometers. All right. So this is what we're going to get. So from here we have two sides given and an included angle. So let's get the angle at B. So B is equal to, the angle at B is, so get angle at B, that means if from the north to if from the north to the line is 70 degrees, then we know that from this, okay, let me put this way. So we have two angles, so let's get alpha. So B would be, angle at B would be 70 degrees plus 180 degrees, or Okay, 180 degrees minus 70 degrees. That will give us a B is equal to 180 minus 70, 110 degrees. What's the reason here? Angles on a line. So if you observe, you discover that this and this they are angles on a straight line. This is a straight line, and you have this line. So 0 degrees plus alpha is angle of the straight line. So you get angle B. So now we have an included angle and two given sides. So we're going to use the cosine rule to find a distance A. This is the starting point of the plane, and then the final destination of the plane. Using the cosine rule, line AC squared is equal to 400 squared plus 600 squared minus 2 times 400 times 600 times plus 110 degrees. 400 is 1,600, 160,000, 160,000 plus 360,000 and 600 squared minus 2 times 400 times 600 times cos 110. That's minus 164 164 169.6 164 169.67, and this will give us, let me add this part. Okay, minus times minus will give us plus. That will give us 160,000 plus 360,000 plus 164 169.7. So I'm going to add up everything. 160,000 plus 360,000 plus 164 169.67, that is 684,169.67. So line AC is equal to the square root of 684,169.67, and line AC is equal to square root of 684,169.67. That is 827.11515. I'm going to correct the answer to the nearest kilometer. So line AC approximately equal to 827 kilometers to okay, so 3 significant figures. So B, this says, on what bearing must the plane fly so that it returns to its original point? So if the plane must return to its original point, which is A, must fly in this direction from, this is the last point of the journey, so it must fly to this, fly in this direction, which is, the bearing must be from C, from C. So let me draw the diagram again. So I have here A, point A, and then I have this, no, not, sorry, give us this, and here is 400 kilometers, and then from the north you have here this is C, again like this, and here is 600 kilometers. Okay, and then from here 070 degrees, degrees. All right, so since we are going to get the bearing of A from C, what we're interested in is this. Okay, but 070 degrees is alternate to this, so let's call here E, and we don't really need all of this part from here to here. What we are interested in is from this line to this line, which we call B. So we have to look for A. No, we already know A to the 7th degree by virtue of being alternate to this side. But because it is from this point to this point, we need to know only from here to here. So that means we need to subtract B, which B from A, or we need to subtract the value here from A. We need to, okay, yes, we need to subtract the value here from A to be able to get B. So for us to do that, we need to get this angle C. And how do we get this, how do we get the angle C? Let's see which condition it fulfills. From our analysis, we know that this angle here is 110 degrees, which is B. From here, it's 110 degrees. So we know here is C. And then we are looking for angle C, which we can call theta. So theta and here and this angle here, so that's sine rule. So using the sine rule, this is sine 110 degrees over 827.15 equals to sine alpha, sine theta over 400. So let's go on. Sine theta is equal to 8 to 400 sine 110 degrees over 827.15. 400 sine 10 divided by 827.15. 0.45, 0.4544. So theta equals arc sine 0.4544. 27.0 degrees. The theta is 27.0 degrees. So, but the alternate angle, which is 70 degrees, is the whole of theta plus A, and we want to get B. You know, so B, from what we can see, we can say theta plus A. Okay, theta plus A will give us this alternate angle 70 degrees. So we can say that A, but A, since, okay, I need to say but A. So since A is equal to 70 degrees, since A is equal to 70 degrees, using alternate angles, so B is equal to get B, A is from this line to here, and theta is from here to here. So if you remove if you remove theta from A, we are going to get B, which is just from here to here. So B is equal to A minus theta. B is equal to A, which is 70 degrees minus 27 degrees, and this will give me 70 minus 27, 43 degrees. So B is 43 degrees. Now 43 degrees plus 180 degrees, the bearing, so the bearing of A from C, or better way to say is that the bearing of the plane from its original point. Okay, the bearing of which is exactly the same thing. On what bearing must the plane fly so that it returns to its original point? So it must fly in this direction for it to return to its original point. So I say the bearing of A from C, or the bearing of A from C is equal to 180 degrees plus B. 80 degrees plus B. Now give me 180 degrees plus 42 degrees. That is 180 plus 43, 222 degrees. C says how far north and how far east is the plane from its starting point. So how far north is the plane from its starting point. So how far north will be me from here, then east move it from here down to this point. So this will give us 90 degrees. Let's call here, this is B and here's D. So for how far north means we are going for BD. So BD, and this is our angle. So this is adjacent and this is hypotenuse. So in triangle BDC, using the cosine ratio, adjacent cos 70 degrees is equal to adjacent BD over hypotenuse 600. So BD is equal to 600 cos 70 degrees. That will give us 600 cos 70 degrees. 205.12. 205.21. 205.21 kilometers. But that's not the from here. The question says how far north is the plane from starting point. So the plane from the starting point, the total distance will give us AD equal to AB plus BD. So that's how far the plane is from in reference to the final points, how far it has flown from the starting point northward in reference to the position of the final destination. So this will give us BD plus AB will give us total distance. This will give us, so here will be AB is 400 plus BD 205.21, and that will give me 600 plus 400. That's 605.21 kilometers. So that's the distance. That's the distance of the plane northward. Okay, that's how far the plane flew northward from its starting point. Then the next one says how far east is the plane from the starting point. So if you want to know how far east, so this is the starting point. Then to get east from here, we move down to the final, connect the from here, connect it to where you have the final point on your drawing, and then so this is the eastern direction. So we are going to calculate DC. So from triangle BDC, using the cosine ratio, we're going to have cos 70 degrees is equals is the cosine ratio opposite over hypotenuse, so sine 70 degrees. So using the sine ratio, sine 70 degrees is equal to opposite, which is CD over 600. I'll call here 6 CD equal to 600 sine 70 degrees. That will give us 563.82. 563.82, which will give me, okay, so that's equal to 562 We're not to correct it, so I'm going to correct it to three significant figures. That will be 5, 6, 4 kilometers to 3 significant figures. So I'm going to correct this 605 kilometers to 3 SF. So those are the answers. 3 towns P, Q, and R are such that the distance between P and Q is 50 kilometers, and the distance between P and R is 90 kilometers. If the bearing of Q from P is 0.75 degrees, 0.75 degrees, if the bearing of Q from P, so P should be here, so P is here, point P, 0.75 degrees. This is Q. The bearing of Q from P is 0.75 degrees, just like this. And the bearing of R from P is 310 degrees. 310 degrees will come this way, so that means I will have to start again. The bearing of Q from P is 0.75 degrees, so my P will be here. So that when I'm getting the bearing of R from P, which is 310 degrees, I'll be able to come up to 0.75 degrees. This is my Q, and this is P. So Q and P, the distance between P and Q is 50 kilometers. 50 kilometers, and the bearing is 0.70 degrees. 0.70 degrees. That's the bearing. And the bearing of R from P is 310 degrees. 310 will move like this. So let's look at the distance. So say this is R. So PR such that the distance between P and Q is 50 kilometers. The distance between P and R is 90 kilometers. So here is 90 kilometers, longer than this distance. So this is R. Next is to connect P and Q together. So when connect, it's going to naturally look like this. So RQ. So here, from here to here is 310 degrees. 310 degrees. So we need to know here. Let's call it A. So if here is 310 degrees, A will be A is equal to 360 degrees minus 310 degrees. Why? Angles at A points. So A is equal to 360 minus 310, 50 degrees. So if A is 50 degrees, the total angle here will be A plus 70 degrees. So angle P, since it's a triangle, the total angle at P is equal to A plus 70 degrees. And A is 50, so 50 degrees plus 70 degrees. That will give us 50 plus 70, 120 degrees. So let's look for question says find the distance between Q and R. So we have an included angle on two sides. So this will physical sine rule. Using the cosine rule, Q and QR squared is equal to 90 squared plus 50 squared minus 2 times 90 times 50 times cos 120 degrees. And that will give us 90 squared is 1100 plus 50 squared 2500 minus 2 times 90 times 50 times cos 120 minus 4,500. And this will be 8,100 plus 2,500. Minus times minus will give us plus 4,500. That is equal to 8,100 plus 2,500 plus 4,500. 15,100. Line Q R is equal to square root of 15,100. Line Q R is equal to 122.88. So I'm going to correct to three significant figures. Therefore, line Q R is equal to 123 kilometers to 3 SF B. Bearing of R from Q. Bearing of R from Q will be from here like this. So yeah, we need two things already from the north to the south 180 degrees. So here we call it A and we call here B. It's already here. Call here B and call here C. Okay. Yeah, let me call here beta, angle beta. Though it's Q angle Q, but let me just indicate it by beta using beta. Okay, so the bearing of R from Q, bearing of R from Q is 180 degrees plus B plus beta. So B can be gotten from here, alternate angles. So B is equal to 70 degrees using alternate angles. So using sine rule, using the sine rule, sine 70 degrees over QR, which is 122.88 equal to sine beta over 90. So sine beta is equal to 90 sine 70 degrees over 122.88. Sine beta is equal to 90 sine 70, 84.57 divided by 122.88. Sine beta is equal to 0.6882. Beta is equal to arc sine 0.6882. Beta is equal to 0.45 degrees. Okay, so beta, we got beta because we need this value. We need the value of beta to get the bearing of R from Q. So we say the bearing of R from Q is equal to 180 degrees plus B plus beta, and that will give us 180 degrees. B is 70 degrees, then plus beta, which is 43.45 degrees. So 180 plus 70 plus 43.45 293, 293.45 degrees. So approximately, the nearest degree will give us 292 degrees to the nearest degree. A little note: observe that the angle given here is 0.75 degrees, but what I use here is 0.70 degrees. So let me just change this to 0.70 degrees because I've already done a calculation. So if you do your calculation 0.75 degrees, your answers will be slightly different. So, but because I've already done a calculation in 0.70 degrees, I will leave it like this. But in exam, please don't change the instruction. Use whatever is given to you.